All right, so we have 10 minutes for debriefing. So the way this works is that in the last 10 minutes, I'd like to talk about things that people found difficult or challenging or interesting, so that we can kind of have a common experience out of this. So as I'm talking, you can upload to Piazza what you have. It's not essential that you got done. I just want to know how far everyone did. And then I'll make a determination whether we spend more time next class meeting on this lab or whether I think it's not essential. So the reason that we're having the labs right here and there is that you instantly start thinking about things. And it's been working out like a charm because I've overheard people saying, well, what are the types of these things? And so that's what I wanted you to start thinking about. So in a strongly typed language, everything has a type. So over here, when I say var x, and I'll put a 0 in here, then the name is x, and then Scala informs me that the type is int, which actually I gave here, but otherwise it would have inferred it, and then it gives a value. So everything has a name, a type, and a value. That value might be permanent if it's a val, or it might be changeable if it was a var. And the name, of course, is whatever name I gave, and the type is either what I specified or what was inferred. So over here, when we look at triple, so we say val triple equals, and then we put in our anonymous function in here, what we get back has the exact same format. The name is triple, the type is this thing in here that we'll look at in just a minute, and the value is given as angle bracket function 1. It doesn't have any better way of showing us what the value is, because by this time it's already compiled it into a function. And what was it going to do? Show us the compiled code. So it just lists it like that. So notice that the stuff here between the colon and the equal sign is the type. So a function type is expressed in Scala syntax as parameter types, arrow, result type. That is how a function type is expressed. You might say, well, that's a stupid way of writing out the type. But after all, in Java, if you have an array type, you write it as int bracket. Right? That's an array type in Java. So it's not really totally obscure to write it like that. That's, here you say, I'm collecting integers, and here you say, I'm mapping integers to integers. The reason they use the parentheses, well, you might have two parameters. So an example would be addition. Addition of integers has this type. So everything has a type, and the function types just look like that with the arrows. And so I think so when you see one of these with these types, I don't think it's particularly unnatural. It's just odd because one hasn't typically seen those. Of course, in C++, you would have seen something like that. In C++, what would be the type of a function that takes an integer and returns an integer? You would write it like that, right? In C or C++, that would be a pointer to a function that takes an integer and that returns an integer. No one likes these type declarations in C++. They look icky. And part of the reason they look icky is these parentheses in here. You wonder why. So in Scala, they always have the syntax that you have parameters first and then the return type, instead of putting it first, which is kind of dumb. And you have a better syntax. All right, so that's one thing. So the other thing that people asked about is what's the deal with this program, the REPL? Oh, you may see Emacs on top here. I'm running the REPL inside Emacs here, which has some advantages and some disadvantages, but my fingers are used to it. The advantage is it's very easy to copy and paste from another Emacs buffer into it. And eventually you'll see the light. But right now it's just fine to run in the shell. But so so just imagine this thing was a shell window. The REPL is it's called the REPL for read, evaluate, and print loop, because it sits there, it waits to read something, and then it evaluates the answer, and then it prints the answer, and it does it again and again. That's why it's called the read, evaluate, print loop. And it's not the most important part of Scala. Scala does have a compiler, just like Java does, and it has a virtual machine runner, just like Java does. But it also has this REPL that's really useful for experimenting. And so what I always do when I program in Scala is I have my regular big iron IDE somewhere, but then for quick experiments, I always have the REPL open at the same time, and I copy and paste stuff into the REPL. I try something out, it doesn't work, I fix it until it works in the REPL, and then I copy it back into my regular editor window, and it makes for a very nice and fluid way of doing experimenting. For example, in step 4, I said, well, strings in Scala are kind of like collections of characters, and you can run filter on them. And one of the things you ask and say, well, how does it work? And the answer every time that you ask, how does it work, try to come up with an experiment that you can run in the REPL. The REPL is your friend, because you can just do any stupid thing. So I have a string, and we'll just want to see, how does something work? And so, does it take characters? Well, we'll just give it a try. Now, what could I do with a character? I don't know. Replace it with 2x. See what happens. Okay. So now it gives me back a collection of numbers, 98, 100, and 102. Why the heck? Yes, exactly. Well, actually, of course, it takes the Unicode value, right? ASCII, so yesterday. But so it takes the Unicode value and multiplies it with 2, and it's no longer a character. Well, what if I wanted it a character? You don't know enough Scala to do that, but I will show you. And then, as a little known fact, that the string 123 multiplied by 2 is the string BDF. Yeah. So, trivia fact of the day is that 2 has Unicode value 50, and the lowercase d has Unicode value 100. Those are the 2 fixed points that are always important. Now, that wasn't the question. This is obviously useless. We were supposed to eliminate spaces. So let's do that. So we had just for grins, what are we going to get out of it? Aha! I knew that. So now we need to test that x is a space. I didn't want to use map. I wanted to use filter. And so now you see, I was stupid and I used map instead of filter. But there's actually a little bit of a lesson here. Now I can kind of visualize what map did, right? It gave me false, 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 true, false. And by just quickly looking at this thing, I said, oh, well, that was kind of interesting, but not what I wanted. And so you kind of intuitively, you learn more things about it, and that's an experience you would never have in Java. Because in Java, you compile the thing, and you just, you want to get the whole program running. You never get to play with the bits and pieces. So it's good old filter. That wasn't so good. What did I do wrong? Yeah, so I guess I should have put in the non-spaces, right? And here we go. Okay. Now this kind of iterative thing happens all the time when I play with the REPL. I never get it right the first place. Something different happens. Something interesting happens. But so I've come to the point where when I need to read something in the documentation, which is not always all that good, I say, well, whatever. I just run a few experiments and I see what it's really doing. And like I said, in Java you would not do that because you would have to fire up the clips. You'd have time to make a cup of coffee, to wash your dishes, to vacuum the house. Then by the time you're done, Eclipse is finally ready for you. And you just would never just do it for a quick experiment. In Scala, on the other hand, you always do that. So if you have a question, just run a quick experiment, and it's kind of easy and fun. So a lot of people really like this aspect. And all of the languages that we're going to be seeing in this class have the same kind of fluid feel to it, that you can run these quick experiments. Now, I must say the Scala REPL is actually very nice. And the reason the Scala REPL is nicer than all the others is that res thing. Remember each of these variables here? Oh, by the way, why is it res 48? Because I've been having this thing running for 3 days. Because I literally use it all the time. It's come to the point that when I need to figure out a tip or something, I run it in the REPL. Because you have these old answers back, so I might actually want to do something with this vector, and I might just might say, many of them were false? And there were 18 false ones in there. And you can see, by the way, a nifty little shortcut that we're going to be learning in the next lecture. From today's syntax, what you would have had to write is Boolean. So anyway, the point of the REPL is you can always refer back to these old results. So it's very common in Scala. You build up some big fat result, and it's not quite like that. And then you massage it again. You just pick it up and you attach another map or filter to it. And then what then happens is I say, oh, if I do this and this and this and this, I get the right result. Then I harvest it all, copy it back into my actual program, and then I move on. All right. The other thing I want to briefly bring up is the homework. So where's my schedule? So on September 6th is the last day to drop, and also as it happens, it's the first homework submission, and stupidly I didn't put the link on it yet, but I will this afternoon. Here it is. And so it has a bunch of Scala things. You should start looking at it now, and we're going to be using Mercurial to submit it. And what's important to me is that you submit it in two parts. That bicep. Oh no, these dates are wrong. I need to fix them. That you want to submit them in a couple of parts, and I'll give some more instructions as to what you should do. And so in the first draft, the easy ones should kind of work, and the hard ones, they should be to the point that you've at least gotten started. And I'm going to look at that in Mercurial to see that you've gotten started, and that way you get to ask questions about the homework. So what I don't want to have happen is that around September 26th, September 3rd, is that around September 12th, people say, gosh, the homework is due tomorrow. I haven't even looked at it. So that's where the stages come in. So as soon as I fix that link on the schedule, have a look at the homework and start getting going with it. You can start doing some of the easy part of it, and you can definitely do everything after next lecture. Okay, any questions? So submit what you have to Piazza. Like I said, it's I don't want you to be done with it. I don't want you to submit it tomorrow morning. I want you to submit right now what you've got, so that I have an idea. Yeah.
What are the instructions for Mercurial submission?
Oh, they are at the end of the homework assignment. So does it? Here.
Oh. You submit it to the shelf, to the SSD?
Yeah. But you can. I mean, it's Mercurial. You can do anything that you want. But if you want me to help you out with problems, you better use the shelf. Yeah. What I was hoping you would do is that you would answer the question that I posted. I have a question that says, please add your answers to lab 1. Can you? Yes. I guess it's hard for me to know what it looks like for students.
It says 4 other users are still editing right now.
You can't do it? And so it won't let you add to it?
No, I don't really understand the flow of this application.
Well, it's not really meant for submitting answers. I just didn't want to toss another application into the mix.
So someone posted it, and
so you have to do it serially, one after the other?
yeah, but it's asking us to start a follow and ask a new follow. We can't really edit the student's response.
Okay, so someone put in their thing, and you can't post your thing. Oh, just post it in the as if it was an answer. Okay, as long as it appears in the answer. There you go.
We still have time to do it.
I want you to put it in right now. You can on your own free time do whatever you want.
Okay.
Okay, now we're good?
So there's some left.
What's that?
We'll learn some left.
That's fine. That's fine. You're not expected to get everything done. I've always put in more so that the fast ones don't get bored. Like these guys got this to part 4. And so if on your own time you're interested, you can work through it. Okay, so work. Well, yeah, someone else would. If this really doesn't work, I'll set up a different system. Right. Let me see what it looks like on my end. You know, if it's too annoying, you could just send me an email. And what we'll do next time is we'll just use SSH. Okay, I can't figure out why this is not easy. So for some of you, it shows up like as comments.
There's like this, the first one, the student's response.
Oh.
Like the main response, and then there's like further discussion or whatever.
I see. I see. Well, it does show up like in a.
I think this is fine.
So you guys got your copy?
Yeah, what's this?
Okay, you got yours. Okay, what happened with yours? You're just gonna give up. That's fine. That's fine. I just want to have it.
Hello?
Yeah.
I'm sorry. This goes here.
Did you guys upload yours? No. You guys uploaded yours? And you guys uploaded yours? So we're all set? Oh, that's wrong.